Thank you. Well, to give you a little bit of a background here, we can start with stating that sometimes it's a little bit tricky to foresee future ship positions when maneuvering in ports. And a natural way of having a support for this is a conventional predictor or a dead reckoning technique, where you use speed over ground, course over ground, and rate of turn to predict the coming ship positions. This is a simple one. If you would like to have a more accurate one, ACCSEAS had developed a dynamic predictor, which also uses normal parameters, but also depth, draught, trim, wind, rudder angle, propeller pitch, and RPM, as well as an hydrodynamic ship model predicting precise ship movements in some seconds or some minutes ahead. And that is, of course, to reduce risks of hard landing or collisions with the berth, with the ramp, or with the dolphins and so on. We have installed that, or Stena Line has bought that from us, and they have installed that in several of their ships. And the result there is that they are very positive to this technique among the users, and it is very helpful in maneuvering in ports. In efficiency project, we did an investigation of exchanging this kind of information between nearby ships in order to avoid collisions. So we tested if that was interesting and could help in that respect. But the conclusion there was that this exchange of predicted positions, to know these predicted positions was not really interesting for the nearby ships. It was too much information, they said, and it was not really the predicted positions that was interesting, but what would they like to have was the intended course. That was interesting. So the conclusion was that it was not very useful for collision avoidance, the exchange between nearby ships. But we can state that the dynamic predictor itself on board the own ship is very helpful for maneuvering in ports. And then we came here in ACCCSEAS to see if it would be interesting to exchange this kind of information between the tug and the ship when using tug assistance. And could the tug operation be more effective using this exchange of predictor information? And this service is now then only proposed to be used in the beginning of a voyage, in the end of a voyage, in a port, and it was for planning minutes and seconds ahead. So that is not any strategic planning, it's direct planning. And this was the aim in ACCCSEAS for us, to test such service. And we started with developing the technique and implemented this dynamic predictor in our seaman simulator software. And we put the predictor into the ship simulator and into the tug simulator. And we also facilitate the exchange of this information between the two systems. And then we planned and did carry through some simulator testing, and we measured some parameters that we thought would be interesting to see. And that was time period over the operation, how long time it take took, and speed when landing on berth, repeatability of the maneuver, and safety margins. And we did some interviews with pilots and tug masters as well. Here is its screen dump of the simulator view. You see the actual position of the ship, the red, and some predicted position in green, and the black one is 3 tug boats. We implemented this ship EPD from DMA and used that presentation, and we also implemented a dead reckoning predictor for comparison with this dynamic predictor, and we put in this hydrodynamic predictor model into the system. We tested with a small LNG carrier with a length of 155 meters and a draught with 7.35 meters. That was in loaded condition. And the bow thruster was disabled, and we'd use an azimuth stern drive tug to combine with. And we tested the simulator within Gothenburg area, and in a southwest wind of 10 meters per second. That was a predominant wind direction and speed in the area. No current was used. And the simulator environment was 330 degrees view, and we'd use this. We have a conning display, we have this ship EPD, and we have an open software chart display, and we have this realistic hydrodynamic ship models based on our model testing and the long experience we have with that. We had put up some test runs here, and that was, we started with 5 different tests, and we did it in arbitrary order, and we did it in 2 runs. And the first one was to test with no predictor at all. The second one was using this simple dead reckoning predictor that was transmitted this information to the tug. And the third one was the predictor, dynamic predictor, and this also sent to the tug, but no forces coming from the tug to the ship simulator. The fourth, then we also exchanged the idle forces from the tug to the ship simulator, and that was the idle forces that was heading, engine RPM, and pitch was creating these idle forces. And the last one, we tried to emulate real forces, which was not that idle then, due to the pull and pushes in the tow lines and the ropes. We tried to come up with a more realistic forces, but that is more or less, well, it's another one, but about the same type of conditions. But that was more statistic forces. Okay, and what was the result then? Well, due to time constraints, we couldn't do that many tests that we have planned. So we did a very limited test run here, and we would like to enlarge them later on. But for the time being, this is the result we got. The pilot, he said that he considered that this dynamic predictor with or idle or resulting forces to be an additional help. That was stated by him. And the simple dead reckoning predictor was not that useful. The tugmaster also said that the situation awareness was improved by this route exchange, or that's dynamic predictor information exchange, rate of turn. So that was stated by the users, but if we look at the statistic material, we couldn't really find significant difference in time, safety margins, landing speed, and so on. So we couldn't draw any certain conclusions from that. But we could see that there was a tendency in the second round that if you have been using the dynamic predictor, you shorten the operation period, and you can say you got some assistance in learning the ship behavior with use of these dynamic predictors. That we could see. But otherwise we have to do more testing really to say that we have material for giving that type of knowledge. So we have to do more tests to look for these significant results, and I think we also have to test a more complicated ship, larger vessel, VLCC, in order to really stress the technique a little bit more. So that was the result from the dynamic predictor. I would also like to say some words of another technique that we also tested in ACCSEAS. And we developed and tested a possible service that we called AIS-based risk evaluation. And that started with collecting historical AIS data in the sound and looking, well, say for 1 year or more than 1 year, and we divided the area into smaller cells and look at the ship behavior in these cells, and look for a predominant behavior, and that could be that was positions, the course, the speed, and so on. And we look for a normal behavior in the different cells. And when you have this normal behavior, you can detect some abnormal behavior. And so if there are ships that deviate from this normal behavior, that could represent a risk, and that could be identified with this technique. And that could be used by the VTS operators to identify ships sailing on an expected route, for instance. And we did a test of this algorithm in using some known accidents in the sound region and a little bit more in this enlarged region. And here, well, I had a video, but you can maybe see the green spots here. Following that's a normal track, normal route in this region, and we tested. I'll show you one here, a real case where the system shows when it deviates from the normal track, it becomes red. So the system did see this abnormal behavior and reacted, and it was grounded in them there. We looked at about 20 real grounding accidents in this region, and the system did warn in almost all cases, except some very few ones where that had very special conditions. And we think that this technique could be used to identify ships diverging from the normal behavior and alert the VTS operators or possibly the officer on watch. And we also developed this technique further in Mona Lisa 2, and the results is very promising so far. Thank you.